are going to be chatting today. My apologies for not having my copy of the notes that we had all this stuff up here where it looks a little bit confusing. We are going to be down here. We're almost through October already. That's wild. It's like we just started. We're going to be writing and graphing in slope-intercept form. If you have misplaced your note packet, I think I still have a few left in the back to rebuild from, but we can get into those as well. So writing and graphing in slope-intercept form. Real straightforward process here, kind of towards the middle of page 4 in your notes here. We're still building on the old notes. We're not, we don't have a new packet as far as those go. So, slope-intercept form. Basically, all you need to know is where the two arrows are pointing. M is going to be your slope. You're going to kind of see why they call this slope-intercept form, right? M is your slope. B is your y-intercept. So when we graph, I'm going to make a little note to the side here. When we graph, we do the y-intercept first, then we do the slope starting at that y-intercept. That's always the order we're going to go in. There's one exception to that rule that we'll see a little bit later. But again, super majority of the time, that's what we're going to do. So here's where we find the information, and here's what we do with the information once we have it. And that information can come in a bunch of different ways. So that's why we've got several examples down here at the bottom, so we can see how this works. So in this section below, it says, write the equation of a line in slope-intercept form with the given slope and y-intercept. Okay, if they literally tell me, here's the slope, here's the y-intercept, I like to actually label them still as M and B, because that way I can look right into my equation and see. And then it literally is just copy. Y equals M, don't forget the x, that x is still there. And then when it says plus b just means whatever your y-intercept is, keep the sign of it. So for instance here, even though it says plus b, you're like, well, is it plus 3 then? No, because the y-intercept is a negative. Could you put plus -3? You could. But I've seen people before when they do that, and then they go to graph it, and they get confused. So like, well, now I see plus and minus, so do I go up or do I go down? So I would prefer that you just, whatever sign that is, that's the sign that's used for the y-intercept, and that's it. You're done. Nothing to solve, nothing to move around, that's it. If they just give it to me as M and B, okay. Y equals M, -2, x, and then my b is -1 or -1. Just write that number. That's it. That's it. So you're like, okay, might actually like this stuff. 3 is the one that gets interesting though. Because 3, you're like, okay, now it looks like I'm having to calculate slope, and we're going to have to do a little more work here. But here's the thing. It is the y-intercept when x equals 0. Because if you stop to think about that for a minute, I'm just going to kind of put this over here to the side. If I've got a graph, okay, here's my y-axis, here's my x. When x is 0, Anywhere along here, x is 0. And where is that? It's on my y axis. So this is telling me that b equals 2. That's my y-intercept. Again, because when x equals 0, the y value is somewhere on the y-axis. So that's telling me that that's where the y-intercept is. So, now, for slope, though, I do have to do a little bit of work. I need to pick two of these coordinates, because remember, anytime you see a chart that's x, y, that's just coordinate points. So what I'm going to choose to do, I'm going to use these 2 points. You could use any 2 points here. So I'm going to call this y2, y1, x2, x1. And I'm even going to write the slope formula back down here. I mean, we've got it in our packet, but we'll just have it here for us too. Y-intercept? I just put INT for intercept because it's a little shorter. So here is my little mini slope equation that we were dealing with last week. And if I label all my points, and again, you could even label this y2, y1, x2, x1. You could do that too. But if I do it this way, now I can do, I literally am just substituting the numbers in. Three minus 2 is 1. 2 minus 0 is 2. And I've got my slope. Now, one thing I did notice when we were on the quiz, okay, is making sure that we're staying simplified. So if you're not sure your fraction's completely simplified, you can always type it into your calculator. Just a reminder. And then if you have a fraction or a decimal, and you need to simplify that fraction, this is how you do it. Math, right over here under alpha. And 2 enters, and then you're going to get it back. So that was the simplest form of my fraction, or my slope in this case. And so I get to this point, and now it took me a little bit of work, but I've got B, I've got M. Now I'm ready to make my equation. Y equals M X, and that's a positive 2, so I'll put a plus 2. And I've got my equation. That's when you're going to get the most work, when you have a situation like this. But again, if I've got this right there with me, it shouldn't be too rough as far as that goes. So, what if, oh dear, what if, as we flip over to 5, what if I'm just given a graph? Okay, we can do this. So remember, my B for my English people out there watching this video later, yes, that should say where does the graph cross the y-axis, not where it is, but I kind of changed my mind midstream. What you're going to do on a problem like this is, here's my y-axis. You're going to find where your graph is crossing it. And whatever the y value is there, that's going to be your B. That's going to be your y-intercept. And then to find your slope, to find your m, we're going to do what we were doing before. We're going to find another point somewhere that's going through the crosshairs, the intersection here. And sometimes you're going to have multiple options for that. But it's got to be through the crosshairs, the intersection. Because if you don't do it through the intersection, it's not going to be accurate. So once I have that, I can pick any pair I want. Let's say I use these two. So remember, slope is rise over run. I'm just going to mention that over here too. So I go, to get from here to there, I go up 1. So that's positive. And I go right 1, 2, 3, 4, which is also positive. If I go down or left, that's negative, but here I went up and right. So that's positive 1/4, and now I got what I need. Y equals mx plus b. Do I have to put the 0 if it's there? No. You could just put y equals 1/4 x, and we would assume that that's plus 0. But if you like to be a creature of habit, and you're like, I always want to put a number there and a number there because that makes sense to me, put the 0. Absolutely put the 0 if you need it. Now, there are a couple of exceptions to the rule. There always has to be, right? So I get to number 5, and I'm like, wait a minute. Hardy, it doesn't cross the y-axis. It's like it's over here. So what do? If you have a time, but there isn't one. And you're like, well, wait a minute. I got another problem. If I remember back when we were doing these before, if it's a vertical line, my slope is undefined. This seems like it's going to be really complicated, but it's actually very simple. Here's what you do. What's the x value that whole line is going through? What is the x value that line is going through? 3. Just write x and the number that the line is going through. Because undefined or vertical lines, if you ever have a vertical line, which again is up and down like the one we have here, it's just x equals and the number that it goes through on x. That's it. You don't have to do any calculating, anything fancy. You just look and say, oh, it's 3. X equals 3. Up and down is x equals. And you're going to do something similar on number 6. But watch this. So I go looking for b. And I'm looking, I'm like, okay. Runs across the y, that's 4. I just colored right over it. -4. So I put my b. I'm like, okay. So then I try to do slope. So I'm like, okay, if I do my slope, to go from here to here, yeah, I don't go up or down any. I go over 2, but again, 0 divided by anything is just going to be 0. So here's what that's going to look like. If I went to plug that in to y equals mx plus b, I'm fine with you doing it that way, but I will warn you, what's 0 times anything equal? 0. It's like it's gone. Y equals -4 would be a better answer, a more simplified answer, but I'm not telling you that you would have to do it. But here, anytime you have, oh, the room of it all. Okay, hang on a minute here. Anytime you have a horizontal line, one that goes side to side, like we did on number 6, if you just go find where it crosses the y-axis, okay, -4, you can just put that number with y and you're done. But that only works if you have a horizontal or a vertical line. If there's slope to it, if it's slanted, you've got to work through the process. It doesn't quite work that easy otherwise. So, here's what we're going to do with this. Okay? I'm still going to mark, don't have these go far away because I'm going to keep flashing them up on the screen here as we're looking here. So, new packet. Here comes the practice. Write the equation of the line in slope-intercept form. You're like, okay, hang on a minute here. Okay, that very first section that we were doing. So this is exactly like examples 1 through 3 for the first 9 problems. Just be careful that when you're doing it, that you're making sure that your y-intercept, your b, and your slope, your m, that you're watching the order and you're not just writing down the first thing you see. Because here, y equals mx plus b, if you label, all you're literally doing then, m is 2, don't forget the x, b is 5, and it's positive. Bam. And you're good. And you just keep working it right on down. You're like, okay, well, there's literally m and b. Okay. Y equals mx. And again, the plus b just means keep whatever sign is on your intercept. It's 3. You're like, okay. Scooch this a little more. There we go. I get to this one. Find the one. Remember, when x is 0, that's where your b is. So my b is 3. When it comes for my slope, again, you can pick any 2 values you want to find your slope. So I'm just going to, since I didn't use these 2, I'm going to use these 2 for my slope. So y2, y1, x2, x1. Labeling, great idea. You've got the formula here. y2 minus y1, x2 minus x1. Do not try to put that all in your calculator at once if you go that route. -3 minus 0 is -3. 2 minus 1 is 1. Any number divided by 1 is just the number. So now I've got m and b. Y equals m x plus b. And I'm off and running. But you always have got to find the one where x equals 0 if you want to find your b right away. Otherwise, that gets a little complicated. And then when I get to the bottom, examples 4 through 6. So again, it doesn't matter which one I pick. I'll just do the first one because that's what we seem to have been doing. So B is where the graph crosses the y-axis, right there. So B equals -4. I still got to find one more spot that goes through the intersection points, goes through the crosshairs. And once I do, Again, we're counting from one dot to the other. We want to do the rise first. Oops, I got to get this on the sheet if I'm going to do it that way. And again, when we speak rise over run, we mean left or right, negative if it goes left, positive if it goes right. Oh my gosh, did I really just do that? I really just did that. Hardy, you are ever in infamy going to put that rise was left over right, because it is not. Rise would be up and down, Hardy. Rise is up, down is minus. I knew what I was thinking, I just put it in the wrong place. Left is minus. Right is plus on the run. Because when we're doing these, we're basically just going to connect the dots. We're just not doing it in a straight line. So if I start here, I went up 3, and I went right 1. So my M is rise over run. So even if you wanted to on your notes where we did rise over run, if you wanted to jot that down there sometime, it probably wouldn't be a bad idea, just so we can have that there. So y equals mx plus b just means keep the sign of b. And we're good. It's like anything else. The more you see it, the more it becomes normalized to you, and you're just kind of looking and seeing how that's going to work. You know what's coming. You're like, no, Hardy, I don't. Because the next 6 are still just that same area. And I'm going to encourage you on this front. If you're like, Hardy, I don't want to do 22 problems. I'll make a deal. Okay? Do the evens or the odds. Do half as much. Do 11. But it's still going to get you enough practice everywhere that you're going to be good. Okay? Full permission being given to only do half. And so then the last part, I'm going to jump in on one. I'm going to jump on 22 because 22 looks a little crazy. When we get to the last part, I see parentheses. So we're going to distribute. We're going to multiply. When we multiply and everything has an x, x times x, there's 2 of them, so that's x squared. Okay, it's not 2x, it's x squared. And then 4 times 1 is 4, but that doesn't have another x. So we just leave it as such. And we do the same thing on the next one. 2x times x, there's 2 x's that we're multiplying, so that's squared. And 2 times 2 is 4x. And now I don't get to quit at this point. That's an excellent start. I got one more step, though. When we simplify, we want to find the terms that have the same variable and exponent and put them together. We're not multiplying anymore, though, now. Everything is plus. So 4 plus 2 would be 6x squared. And if I have 4 x's and I add 4 more, I have 8. So that's what we're on the lookout for with those. So again, keys up front, keys on Google Classroom. Use them as a guide, not to just copy to make it go fast. If you run into questions, let me know. I will be happy to help.